Alright, so our very last shortcut that we're going to talk about with congruent triangles is the HL Theorem. And like we said, we noticed that this only has 2 letters to the shortcut, whereas our others have 3. Well, where the third piece is coming in is the fact that if we use HL Theorem, it only applies to right triangles. Okay? So HL Theorem... So we're using hypotenuse leg theorem. This one only applies to right triangles. So if I do not know that my triangles are right triangles, can I prove them congruent using hypotenuse leg? No. Okay? They have to be right triangles. Now, here's the tricky part, is knowing what's the hypotenuse and what is the leg. If I'm looking at a right triangle, what is the hypotenuse?
The slope.
No. Well, it is kind of the slanted one.
The longest side.
It's the longest side, but how do I know for sure that it's the longest side?
Because those two are right. That one.
Because the other two are legs.
Good. It's across from the right angle. Okay? It is across from the right angle. So we know that we always have our hypotenuse is across from the right angle. So if the hypotenuses of 2 triangles are congruent, and they have a leg, and a leg is just the other 2 sides, okay? So they've got hypotenuse congruent, they're right triangles, and they have another side congruent, then they are congruent by hypotenuse leg. So in example 1, it wants to know, are the triangles congruent by hypotenuse leg? And if so, write the triangle congruent statement, okay? Well, in order to determine hypotenuse leg, what's the first thing that we have to know about the 2 triangles?
If they're right angles.
Good, that they're right triangles. So are these right triangles? Yes, okay. Second thing that we have to know is that we have hypotenuses that are congruent. So if I look at my triangle ALT, which side would be its hypotenuse? AT, good. It's directly across in the right angle, so it's 10 inches, okay? If I look at my second triangle VWX, what is its hypotenuse? Good. VX, which again is directly across in the right angle. So are my hypotenuses congruent? Yes, they are. So they're congruent to each other. Let's mark them with a tick mark. Okay? Now, we also have to show that we have another side congruent. So, do I have another pair of congruent sides? Yeah, what are they? Good. LT and VW are both 6 inches. So they're right triangles, their hypotenuses are congruent, they have a leg congruent, so can I prove them congruent by hypotenuse leg? Yes, we can, okay? Now it wants me to write the triangle congruent statement. Remember with the first one you can write it any way that you want, so I'm just going to call the first one ALT. But when, go ahead.
XWV.
Good. When I name the second one, we've got to line up our pieces. So A, if you look, is between the side that we don't have a measurement for, and the hypotenuse. So if I look at my second triangle, X would be the angle that's made with the hypotenuse and the side with no measurement. Okay. L is the right angle, so it has to correspond with W, and then that would leave V to go last. So yes, these 2 triangles are congruent, and they're congruent by HL, or hypotenuse leg. In example 2, it's wanting us to write a proof, okay? So it's giving me some information, and it wants me to prove these 2 triangles are congruent, okay? So I'm going to start by filling in my columns. You've got statements, and you've got reasons. And what always goes first? You're given information. So the first thing I'm going to do is I'm just going to copy down that given information. So M is the midpoint of QC and SB, and angle S and angle R are right angles. So it doesn't give me any direct congruencies. However, it tells me I've got a midpoint, okay? And way back from the beginning of the year, we know that if we've got a midpoint, it's in the exact center of the segment, which is going to break that segment into two congruent pieces. So if I'm looking here, it tells me that M is the midpoint of QC. So that means that from Q to M and M to C are going to be congruent to each other. So QM and MC. It's also the midpoint of SB, which is going to make from S to M and M to B congruent as well. And so what's my reason for that? Yep, because we knew that if I had a midpoint, that means that I've got congruent segments. So by the definition of midpoint. So there's two congruencies, but we know that I have to have a third piece of information. Any ideas?
Would the vertical angles have anything to do with it for this one?
You could, and if it had, and it doesn't necessarily state, but we are talking about hypotenuse legs, so we know that's probably what we're going to try to prove it by. Okay. Now, if it didn't state, if it just said by any of your shortcuts, then yes, you could look at your vertical angles in the middle and prove that way as well. Okay. But what other information did it give me?
That S and B are right.
Yeah, that S and B are right angles. So if I know that S and B are right angles, what do I know about these two triangles? Yeah, that they're right triangles, right? So if I know that I've got those two triangles, or if I've got two right angles, I've got two triangles that are right. So triangle QSM and triangle CBM are right triangles. And that's just by knowing by the definition of a right triangle. So I've got right triangles. I've got a side congruent. Are their hypotenuses congruent?
Yes.
Yes. So are these congruent by hypotenuse leg?
Yes.
Yes, they are. So the very last thing that you write is your proof statement, which says QSM is congruent to CBM, and that is by the hypotenuse leg theorem. So kind of key thing with hypotenuse leg, A, they have to be right triangles. B, your hypotenuses are congruent. And remember, the hypotenuse is across from your right angle. And then C, you have another pair of sides or legs that are congruent.